All right, we're going to be talking about the most common functional groups there are in our universe. So we have an alkane, right? An alkane, single bonded carbon molecules, pretty much. So anything like this, okay? An alkene is double bonded carbons, right? This is an alkene. Then we have two other bonds. Doesn't matter what they are. All that matters is that there is a double bond right there. So that's an alkene. An alkyne is next. It's triple bonded. Whoops. An alkyne. This is a Y. See? Triple bonded. Whatever that may be. Only thing that matters is that we have a triple bond, right? One sigma bond, two pi bonds, and one sigma bond. All right, cool. Okay. Let's talk about alkyl halides, which is just any, we call it the R group, and a halogen. So this is any type of halogen. Halogen. This is a G. That could be fluorine, chlorine, bromine, iodine, so any halogen. So it could be R, F. This is an alkyl group. This is a K. Alkyl group can be any string of carbons, a carbon chain. You know, or it could be, yeah, any chain of carbons. So that's an alkyl group. Or it could be a hydrogen, right? So this is also an alkyl halide. So the R group can be a chain of carbons or could just be a single hydrogen. Okay, in alcohol, we have this R group. This is an alcohol. This R group's usually a carbon. Okay, so for example, you could have this alcohol. This is the R group, so we could write it as ROH. So this is an alcohol. Thiol. It's a sulfur with a hydrogen and it has some R group. That's a thiol. So for example, have something like this. This is a thiol, a molecule with a thiol group. So you could say that's a thiol. Or you could say the whole thing is a thiol group. All right, an ether. Whoops, I want to keep it consistent. So an ether is an oxygen with two R groups, two alkyl groups. So, for example, we can have this molecule. You have the O right here, the oxygen, and two R groups. Or you can say this is the whole R group. So yeah, this is an ether. Okay, an epoxide could be something like this, where these are carbons, right? You could have two R groups, which could be carbons, right? Or they can also be hydrogens. Doesn't matter. So we can have something like whoops, something like this. This is an epoxide. R, R, O. I don't think I wrote it. Epoxide. Okay, a phenyl is a benzene ring with an OH group. This is a phenyl. Benzene plus OH gets you a phenyl. Okay, an aldehyde, double bonded O with an R group and an H, a hydrogen. So this is an aldehyde. So this could look like this in a molecule. This right here is an aldehyde. A ketone. Really bad at drawing K's on this. Ketone. It's a double bonded oxygen with 2 R groups. So there is no hydrogen. These R groups are strictly carbons. Or, yeah, they're just strictly carbons. So we could have a molecule like this. And this would be the ketone. Okay, a hemiacetal. Looks like this. These are like carbons, right? This is like a carbon, right? So this is kind of an ether. This is an ether. If you really look at it, it's carbon, oxygen, carbon. And then we have a hydroxyl group here. So this whole thing is called a hemiacetal. Hemi means like, you know, 1. So we only have 1. We have 1 acetal here. Which again, if you look at it, it's an ether right here. Hemiacetal has 1 hydroxyl group and 1 ether, pretty much. An acetal has 2 of these OR groups. This is an R, R like this, right? So let me just show you a molecule. For hemiacetal, I'll show you a hemiacetal. It would look like this. This is a hemiacetal. Let me draw it in red. Including that. That's a hemiacetal. An acetal be something like this. This is an acetal. You can also have something cool like this where it creates this enclosed system. This ring, right? See, this is an acetal. This is also an acetal. Because if you think about it, this is like the R group. This is also an R group. And these R groups can be attached to each other. There's no restriction there. So that's an acetal. Cyanohydrin. Looks like this. CN in a hydroxyl group. It's a cyanohydrin. An amine has 3 R groups, has a lone pair of electrons. This is an amine. Okay. An imine, there's an I here. An imine, R group, double bonded nitrogen, and another R group, and it has its lone pair of electrons, which you can just draw as that, right? As a line like that. An anamine is an R group, double bonded R group, nitrogen, 2 R groups, and its lone pair of electrons. This is an anamine. Carboxylic acid, some R group with an OH and a double bonded O. This is a carboxylic acid. Acid halide, R group, OH, and some halogen, X. So this could be chlorine. This is an acid halide. And an ester looks like this. This is an ester. So a carboxylic acid would have a hydrogen here. But for an ester, this R group is like a carbon. So this is an ester. And that's it.